Hey, it's me, Steve. It's August 31st, 2017. Time is 11:35, 71 degrees Fahrenheit out. And this is a Geo-Rant. I am going to talk a little bit about two things, plate tectonics and the predictability and the ability of science to make predictions. I guess a better way to put that. But so I've been following a lot of people's arguments a lot. That's why you've seen a lot of the philosophy stuff and stuff like that. And I just want to show you how just because something cannot be falsifiable in and of itself doesn't necessarily mean it's not a legitimate scientific point. Like take plate tectonics, for example. All right, we can measure the spreading rate or subduction rate or strike-slip motion of plates, of tectonic plates on this planet. We can measure it using satellites. We can bounce lasers off the moon. We have done this. The continents are changing shape, and we can even measure the rate. All right. Now, we can make pretty accurate predictions and pretty precise predictions for what the continents will look like, say, a million years from now, which, by the way, the answer is pretty much the same. 10 million years from now, yeah, I mean, you know, we can accurately predict about, you know, we're pretty confident that we can do that. 50 million years. Now you start running into problems, okay? 100 million years. No. All right? We don't know, but that does no way falsifies the process of plate tectonics, all right? Or falsifies the theory of plate tectonics. We're not even 100% sure of the mechanisms. We think now we have a very firm understanding, or getting to a firm understanding of what drives those plates. But the thing with predictability and being able to accurately predict things in science is that over time, your margin of error increases on most things. And this even includes things that people think are pretty set in stone, like predicting eclipses, you know, predicting solar eclipses by measuring the orbital, you know, parameters of the moon around the Earth. That stuff changes with time. Earth's orbit changes around the sun with time. The moon is slowly progressing outward. Earth's tilt changes over time. And when you can take all these things into account and get pretty accurate models for a certain period of time, but then that breaks down, all right? Because things change. The thing with natural systems, and especially, you know, actual physical things like the planets and the stars and stuff, is that there are new variables that can be introduced over time, all right? And same thing with plate tectonics. Like, about plate tectonics, if we just predict using modern plate motions, we can make a prediction in 100 million years into the future. That's no problem, but it's not going to be accurate, and it's not going to be precise. Why? Because there's other factors than just the plates moving. All right, plate tectonics is driven by the interior of the Earth, and there's still some things we don't fully understand about that. Mantle plumes can change; they can be turned on or turned off, and we're not really sure how. You know, you get two continents collide, that can affect things. So it's not. If you're going to try to falsify a theory, you got to be able to falsify it quantitatively, not qualitatively, quantitatively. You got to show through observation, testability, and stuff like that why that theory isn't valid. You can't just sit there and use some stupid philosophical argument. It doesn't mean anything, especially if your whole premise is wrong. These things are called logical fallacies, and there's a ton of them, and you can look them up. But you know, I guess that's neither here nor there. I was going somewhere, but I forgot. So I'm going to cut this video short, and I guess I'll make this a Geo-Rant, even though it's kind of on the border. But if you have any comments or questions, please leave them. Thanks.